Hello everyone, this is Sangeeta, Assistant Professor, ECE Department, SNS College of Technology, Coimbatore. So today's topic is JK flip-flop. Let us have a small recap about the previous video. In the previous video, we discussed SR flip-flop and D and T flip-flop. So in SR flip-flop, S means set and R means reset, and if both inputs are high, that is S is equal to 1 and R is equal to 1, the flip-flop moves to the invalid state, and this can be eliminated by using D flip-flop, and T flip-flop is toggle flip-flop. Let us move on to the topic JK flip-flop. So why we need JK flip-flop? So it eliminates invalid state and for efficient toggle operation and versatile applications of that is suitable for various counter and memory element. It can be used. So these are the empathy points of JK flip-flop. And with the empathy points, we can define JK flip-flop as. So JK flip-flop is a flip-flop which consists two inputs and one clock input, that is two inputs, S set, that is J, and K reset, and their corresponding outputs are Q and Q bar. So this flip-flop is same as SR flip-flop. So most of the behaviors are same as SR flip-flop, except if both inputs are high, the JK flip-flop will not move to the invalid state. And it can be operated as synchronous mode or asynchronous mode. And this is the truth table of JK flip-flop. As I said earlier, it behaves like a SR flip-flop. So this is the block diagram and truth table, and it can be designed using 4 gates, 4 NAND gates. So J and K are inputs and clock input, and Q and Q bar are the outputs. If both inputs are 0, the output will held at its previous state. This is called hold state. And if the inputs are 0 and 1, it will be in reset state. That is, reset means 0. For example, J is 0 and K is 1. The current state is 0 and the next state is 0. And if the inputs are 1 and 0, the output of the flip-flop will maintain the set state. That is, the output will be high. And if both inputs J and K are 1, the output will be toggled. That is, Qn is 0 and Qn plus 1 is 1. So you know very well, Qn is the current state and Qn plus 1 is the next state. And for the last line, J is equal to 1, K is equal to 1. The Qn is 1 and Qn plus 1 is 0. That is, in SR flip-flop, if both inputs are high, the flip-flop move to the invalid state. But it is eliminated in JK flip-flop and it is toggled. That is, if both inputs are high, the JK flip-flop enter into toggle mode. It is otherwise called race around condition. And this is the characteristic equation, that is characteristic table. So using this characteristic table, and we can use K map to derive characteristic equation. And J is the input, one of the input, and K is the another input, and Qn is the current state and Qn plus 1. If 0, 0, 0, the next state is 0, and for 0, 0, 1, the next state will be 1, and likewise the last input is 1, 1, 0, the next state is 1, and for 1, 1, 1 it is 0. So using this, and we can derive the K-map by mapping the Qn plus 1 by using 3 variable K-map, and we can get group 1 for J bar K Qn plus J K bar Qn, and for group 2 J K bar Qn bar plus J K Qn bar. These are the characteristic equation, and the last one is the excitation table. As I said earlier, the excitation table is used to know what will be the input should be given for changing the flip-flop from one state to another state. And so hope this video will help you to understand what is JK flip-flop. And this is the assessment time. First question is why we need JK flip-flop, what is race around condition, and the last question is characteristic equation of JK flip-flop. And the answers are JK flip-flop is mainly used to eliminate the invalid state of SR flip-flop, and the raised around condition is for S is that is if both inputs are high, the flip-flop enter into the toggle mode, that is called a race around condition. And the characteristic equation is JK Qn bar plus JK bar Qn, and it is derived from the characteristic table. Thank you.